All right, so let's actually try to use these operations on some rational expressions where we have some variables in the mix, and monomials and even polynomials. So number one, we have monomials, right? And we've actually done problems like this before using our exponent properties, right? So what we can do first of all is with the 9 and 27, those we don't need exponent properties because those aren't in exponential form, right? Those are just plain numbers, and so we're just going to reduce like we normally would. The greatest common factor between 9 and 27 is 9. So 9 divided by 9 is 1. 27 divided by 9 is 3. So we divide by that common factor. So I'm going to bring over the 3 here. And the 1 that on top, I'm going to leave that out because I only need it if there's nothing else there, right? If there's something else there, then that 1 can be invisible. If there's nothing else there, then I'm gonna put the 1 back in. All right. So now let's look at the a's. So I have a squared on top, a to the 4th on the bottom. Remember what we do with x or like bases when we divide is we subtract the exponents, and so you go where the bigger exponent is. So since 4 is bigger than 2, we want to bring our a's to the bottom. All right. So we're gonna have a on the bottom. That way we can subtract 4 minus 2, the bigger number minus the smaller number, and then that'll give us 2, right, as our exponent. So we have a squared. B's, same thing. 4 is bigger than 3, so I'm going to bring the b's to the bottom. And then I'm going to subtract 4 minus 3. And that gives us 1, but we'll leave that 1, we'll make that 1 invisible. Because b to the first is just b. All right, and then finally, we have c all by itself, so we'll just bring that right over. Since there's no other c on top, it's just going to stay the same where it's at. Okay, and it turns out we have nothing left on top, so we do need that 1 after all. So put that back in, and that's our final answer. All right. So number 2. So here we have polynomials, right? We have a binomial on top, trinomial on the bottom. So now, just like with numerical fractions, we want to divide by common factors, right? And sometimes, remember, like we saw in one of those examples, sometimes it's hard to see what the common factors are, what the factors are in general. And so what we need to do is factor them. With numbers, we can do a factor tree, but with polynomials, it's not that simple, right? So we have to use one of our factoring techniques. And so, for example, in the denominator, we have a complex quadratic, right? It's a trinomial. If we check for a common factor, which is what we want to do first, there's no common factor bigger than 1 between 3, 13, and 10. So we're stuck with that. So since a is bigger than 1, it's a complex quadratic, right? So what we have to do is we have to multiply a times c, 3 times 10, and that gives us 30. So then we're trying to find two numbers that have a product of 30 that have a sum of 13, right? Now remember that our signs need to be different. So it's tempting to want to pick 3 and 10, but remember that, and this is the sign of the bigger number here, right? So remember that this would be 3 minus 10, right? 3 plus negative 10, and that doesn't equal negative 13. So then we would check, okay, what are some other factors? So we need to have the signs need to be different, and they need to add up to 13, right? So let's check, since we need a bigger difference, we want to get these numbers further apart, right? So I'm going to try 2, and 30 divided by 2 is 15. So I have 2 and 15. 15 is a bigger number, so it's going to be negative, and 2 minus 15 is the one that's going to get us negative 13, okay? So those are my two numbers. So what I'm going to do, I'm going to put those in parentheses just like we've done before. V here, V here. I'm going to put 2 and 1. It's positive 2, right? Then I'm going to put that negative 15 in the other. Okay. So remember that this tells us the sign of the bigger number. That's why this is negative. And then this tells us whether the signs are the same or different. So since this is negative, the signs are different, and that's why we have a positive in front of the smaller number. Okay, so now what we're going to do, since it's a complex quadratic, is we take whatever a is and we divide by it, right? So we put that in front, or excuse me, we put that underneath each of those numbers. And then we reduce. So 2 over 3 doesn't reduce. So this 3 is just going to come to the front of the v, and the 2 is going to stay there, right? So it'll end up being 3v plus 2. Okay, and this other one, 15 over 3, that does reduce. That reduces to 5 over 1, right? So then that's just going to be v minus 5. So I'm going to bring that over, 3v plus 2 over v minus 5, or excuse me, times v minus 5. That's all in the denominator. Okay, now the numerator. The numerators are a little tricky because the leading coefficient is negative, and we want it to be positive. So sometimes when we have an equation, we can multiply by -1 or divide by -1, but this is not an equation, it's an expression. So we can't just multiply or divide by whatever we want. What we can do is we can factor. So here we can factor out a -1, right? And then what that'll do is that'll change v squared to a positive, and it'll change 25 to a negative. Okay, so now my leading coefficient is positive, which will help us to match up better with what we have down here. All right, so if your leading coefficient's negative, factor out a -1 or just a negative, and that'll change the signs of everything when you put them back inside. Okay, so now I can see that this is a difference of 2 squares, right? Those are both perfect squares, and I'm subtracting them. The signs are different. So what I can do is I can set this up as a product of 2 binomials. I'm going to take the square root of v squared, which is v, so I put that here and here. I'm going to take the square root of 25, which is 5, so I put that here and here. Then we just put a plus and a minus, and we're good to go. Okay, so it's negative v plus 5, v minus 5. All right, so now we can actually see what factors we have, right? So we can reduce by common factors. So here the common factor is v minus 5. So we can divide by those. And then what we have left on top is negative v plus 5. And then the bottom 3v plus 2. Okay. All right. If you want, you could distribute this negative here. It's not necessary. But another way to write it would be negative v minus 5 over 3v plus 2. Okay. So this would be your final answer. Either one would be totally fine. Now, one thing I want to point out is, remember, we talked about this the other day. You can't just reduce or cancel these v's out, right? Because those are part of a sum or difference, right? So so remember that when you have a sum or difference, that's a package deal, right? The only way we could cancel out the v minus 5 is to have another v minus 5, right? The only way I could cancel out this v plus 5 is if I had another v plus 5, which I don't. The only way I could cancel the 3v plus 2 is if I had another 3v plus 2, etc., right? And so watch out that you don't try to, here these are all factors because we're multiplying them together. Those are monomials. But whenever you have a binomial or trinomial, you cannot just cancel out like this term with this term. Even though those do have a common factor, this is a package deal. So you can't reduce the 25 without reducing the v squared. And 10 and v squared do not have a common factor. So, all right. So make sure that you resist that temptation and don't try to just, oh, v squared with v squared, those cancel out. That doesn't work that way, okay? Because you're adding and subtracting. So you have to factor like this, and then you can see what the common factors are and reduce from there, okay?